Hello again, everybody. This is Tom from Every Step Calculus, everystepphysics.com. Another problem in Newton's method. I added a graphing program in here so that we can graph these functions when you do Newton's method, so you can see where it crosses the x-axis and get a good idea of what they're trying to do here. Newton's method uses a formula to find where the function crosses the x-axis. And I'll show you how that works here. Index 8 to get to my menu. Already at Newton's method here, so you'd find that with using the cloverleaf pad here on your calculator after you buy my programs and load them in there. And it says busy here, it's loading the program. And here's the formula. Write this on your paper, on your test paper. That's the first thing you do always in a test, and then you'll get 2 or 3 points partial credit, which is enough to make you pass, or certainly help you pass. There's the formula, and we're going to put the function in here. I have to press alpha first in my programs. Alpha. Okay, so I'm going to press alpha, and it's 3 times second sine of x, close off the parentheses, minus x. Now notice the simplicity of these functions that they always give you in these problems. See, these problems are all just puzzles, calculus puzzles that they want you to solve. They don't solve anything useful at all. I've never seen it in all the 30 years I've been programming this stuff. I've never saw one useful thing that calculus does. It certainly is not used in NASA or space exploration or radiology, even though they say it is. It's not, because the reason is because somebody has to design the function, and if you design the function, you know all what you're trying to find out, if you can possibly do that. And then calculus can take the function and do derivatives and play with it and do your puzzle works on it, but it all needs functions here, okay? And so somebody has to design the function. There's no classes on designing functions in calculus, okay? I mean, that'd be like making a graph and then all of a sudden creating a function for it. It's not easy to do and not done normally and everything else. And then when you do that, you don't need to use calculus to take things apart and find out a slope of a line for a derivative and area under a smooth curve for an integral, if you're finding that. So here's the simple function here that they've designed for this puzzle. I say it's okay, we've entered it okay, and here's the graph of it. Now you notice the graph, it crosses the x-axis at 0, crosses the x-axis at a little bit over 2 here, and a little bit over 2 on the negative side here, okay? So that's what they're, well, here, notice, minus 2.24844, okay? Now in other programs, when you put the function in, you know, in my menu here, you'll have critical points and critical numbers. Critical numbers where the function crosses the x-axis, and you use math to find these out here. And then, of course, you substitute that into the function, and you get the y value, which is a point. So you have the number, which is the x-axis, and then the point, which is the x and y-axis. So here they're getting where this is crossing the x-axis. Okay? Press enter. And they give you a single, what do they give you here? x1 is going to equal 2. So we're going to screw down here. We're going to press number 3 here. And we're going to put alpha 2. And they want 5 decimal places, so we're going to put alpha 5. Looks good. So So we got x1 equals 2. This was off of a Yahoo problem that I got on the internet, and I wanted to show you how the guy who answers it this way. Now you can imagine if you put this down, you'd have to figure out all these things. It took him a half hour to do, of course, and putting him into the formula here, which he has here. Or a girl, as generally is a man. I don't know who these people are that are answering these things. And of course, when we put these functions into the calculator, we have to use times in here. 3 times sine of x minus x. The first derivative is 3 cosine of x minus 1. And I'll show you how we find all that. So x1 becomes x2. We put that in here for the formula. And then we substitute the 2 into for the x values in the formula. And here I have to use quotation marks here. That's the calculator won't let me do anything else, but you're going to use parentheses when you you're going to put 3 times sine of parentheses 2, and so you look like you really know what you're talking about. Here's the f of xn, which is the numerator, 0.72789. Here's the denominator of the formula, the derivative, f prime of x sub n, and that turns out to be minus 2.2484. And then you divide it out, and the answer is, for number 2, is 2.3237. 2.32, see, here it is right here, okay? X3 is 2. Now we substitute x2 becomes x3, so we're substituting this now into the formula again now and doing the calculations. Well, if any time there was a place for a program, this is certainly it, to do all this baloney accurately and correctly. And you have this all in your titanium calculator if you buy my programs and load them in here. Plus you get my help. You call me up on the phone, I'll help you with calculus, help you with problems. You can send me tests and I'll show you how to solve them with the calculator here. None of the other things you see on the internet. You can go and see professors in the chalkboards doing all their calculations, or Patrick JMT, which is the best teacher in the internet for calculus. But you still have to memorize all that formulas and all this stuff. You got so much to remember, about all this, and you have no interest in it. You'd like to do it, get it done, and get the heck out of calculus and never to see it again. If calculus was an elective, nobody would take it, okay? But they make you take it, so you gotta do it, okay? So here's x4, 2.2789. Where's 4? 1, 2, 3, 4, 2.24 here. I don't know what this is. .2479. Anyway, the x4 is that. And you can see where from the graph that it's a little bit over the number 2, which we graphed, x5, 2.2789. Notice how it's converged to this number here. So that's what Newton's method does. It converges to the actual point where it crosses the x-axis, okay? So we're going to leave it here now, and you go to my site, buy my programs, and I'll help you and pass calculus, and you'll have my programs for life in your titanium. Don't ever throw it away, because your partner or your girlfriend or your wife or whoever will take some other classes in the future and be with calculus, and you'll have that, or your grandkids or your own kids or whatever will need this stuff for the future. So you never throw this out. Take your calculus books and burn it, throw it in the garbage, But incidentally, calculus books are unbelievably difficult and genius stuff, really, so I have to give them credit. It's unbelievable how they can get all these calculations in there and do all that baloney that they have done in those books. I got 1,300 pages in my calculus. I got several calculus books, but they're about that. Calculus 1, 2, and 3. Unbelievable. Triple integrals, all the stuff that they throw at you, you know. So anyways, go to my site, buy my programs, and good luck in your calculus class, okay? Have a good one.